great. Can you hear me? Favor? Yeah.
Yeah.
All good. Okay, fine. So, welcome everyone. My name is Stefan. I'm the senior system engineer here at PLM Central, and I would like to introduce you to us first of all, and then I would like to hand it over to Felician. So, who we are? PLM Central is part of the PTC partner network. We are based in Watford, United Kingdom. And we provide support, implementation, consultancy, and training services for the PTC product range. So we have over 20 years of association with PTC products, and we have a great record in large-scale digital transformations. Felician, can you put back? Thank you. Okay. Our mission statement is we design innovation, and we support around 200 live customers globally. And our strength is that we value working very closely with our customers. So if you can go to the next slide, Felician, please. So here you can see some of our customers who we work with globally. And some of these customers, they already use MBD, or some of the customers, they are just adopting this concept of model-based definition. So the concept of model-based definition holds a very significant importance for us. And 2 decades ago, encouraging people to embrace CAD was a challenge. Today, however, 99% of the companies incorporate 3D CAD into their product development. And the evolution continues with the next generation approach of product development using MBD. In traditional product development workflows, design information is often shared through 2D drawings, which can lead to interpretation errors, communication issues, and increased time and effort in managing separate documents. MBD aims to streamline this process by embedding all relevant information directly within the 3D model. And we are excited to be actively engaged in this transformation process and helping companies to achieve this transformation. And now I will hand it over to my colleague Felician, who will provide you with a detailed technical insight into MBD. Felician, over to you.
Thank you very much, Stefan. Favor. Good afternoon, everyone. My name is Felician Farkas. I am an application engineer for PLM Central. I have experience in manufacturing, operating different machineries, Kongsberg precision cutters, laser cutter, vacuum forming, and heat vending machines, and more. Furthermore, I am a Creo CAD user. I also use SolidWorks previously. And today I will talk about the commonly mentioned topic of model-based definition. So hopefully you're going to understand a bit more about what is it, and digital track as well. Okay, so let's start reviewing the webinar agenda. Stefan has introduced you to PLM Central. The main focus today is MBD and digital thread. What is MBD? The main component of MBD and the attached product manufacturer information. What does MBD look like in a product life cycle, and how different organizations and stakeholders extract information from the CAD model. 3D CAD model annotation and combination stage. Also going to mention about MBD in manufacturing, machining and tooling. Talk a little bit about digital thread as well. And at the end, I gonna talk a little bit about Creo tools and how they can help MBD. So global competition and growing product complexity demands a smooth flow of relevant information for efficient processing. In a manufacturing industry, the main information source is attached to the CAD model. How the information is extracted and shared from the model during the product lifecycle stage is key. And Creo parametric model associativity and excellent windshield integration provides a direct and real-time product modification and steady, well-managed file format transfer. It also supports auto notification, align the process. So model-based definition is a methodology in product development where the CAD model is the embedded information and center of MBD. And the 2D model is replaced by a more visual annotated 3D digital model. The MBD is often mentioned as a single source of truth. This technology becomes a very powerful asset, not only in the early product lifecycle stage, but also in product manufacturing stage, referencing informations in a later life cycle and highlight just necessary information. The main component of MBD is the 3D CAD model. What does it contains? Product manufacturer information, PMI, and metadata. PMI includes dimensioning, annotation, and symbols, GD&T, geometric dimension and tolerance, notes, assembly information, and more. Metadata, details such as part name and features, along with specific properties associated with each feature. The bill of material serves to organize and manage the list of components and the quantities. And metadata maintains revision history as well. The Creo software family diverse range of tools and windshield integration seamlessly facilitates state transformation across different stages of product lifecycle. And this integration represents a significant strength of PTC, particularly when we employing model-based definition. MBD and the digital thread facilitate collaboration with in-house department, helps communication and share data between other stakeholders and suppliers. Is automatically generate reports in each individual life cycle. So you can see the first bit is the product development, the CAD design stage, where the model is created and the product manufacturer information attached to the model. And that's the key and very important stage for the whole entire model-based definition. Then we go to the design engineering stage, where analysis, simulations makes sure the model behaves and perform optimally. Also, the toolpath creation takes place here, which has the machining stage. I mean, it could take place here. It could take place at the manufacturer place. And this stage has a big impact on validating the model. The next stage is the manufacturing stage, where the production is happening, and also inspection and quality check. I will tell a bit more about this part in the next few slides. The next stage is the supplier and logistics stage. Involves the material order for production, shipping of raw material, and the finished product itself. The coordination of these tasks can be also helped by a well-managed BOM, bills of material and part assembly. The next stage is the sales and marketing stage. Even at the early stage before product launching, take place and use photorealistic rendered image, which can be used to introduce a product or collect feedback on different matter. Product concept animation also can use. I'm sorry, I just forget to. Yeah. And sales and marketing. Yeah. And the next service maintenance. We mentioned about this in the later slides. And at the very end, the recycling stage. MBD support proper disassembly instruction, give information of the material content, and instruction on how to the product needs to be disposed correctly. And this is all attached to the same model, and the information is contains, and that's the important bits of MBD. I haven't mentioned here all the stakeholders and stages, but all these stages have their challenges and dependencies, and that's why the design associativity is crucial to working with a coherent and relevant real-time model along with the whole entire life cycle. So in this short video, I'm going to show you, we will see how to create some annotation and organize them, and also creating different contributions stage to support MBD. Set up a PMI of the product manufacturer information. Annotation is important to help MBD. MBD shows annotation on the model and its associated data elements to define the model. So this is it. That's the most important things of MBD. In this example, I will show you a sheet metal model. So let's start the video. So at the beginning, no animation shows on this video, so I make it visible and select an appropriate plane, the left plane. So the annotation will be parallel with the surface, and a new annotation will be added showing that dimension, the hole size, dimension of that hole size. When annotation created, we can assign to different combination state. Now we add a new annotation, geometric dimension and tolerance. Again, select the appropriate plane. Yeah. We can select the characteristic of the geometric tolerance at we add some datum target here. These annotation all added to the general combination state at the moment, not assigned to any specific state. So now I will show different combination state. See those little tabs at the bottom of the model. You can see all combination state shows different orientation and annotation. The last one is the section view, what you see. A section view orientation with a note of left. We can add new annotation at any time, depends what we want to display. Combination state and these elements can created for specific request, what we want to see. Could be helpful in manufacturing stage to add a specific reference, group different hole size, make notes, warning of dangers or any other notes. So these are some annotation assigned to different combination state. The video demonstrate how we assign an annotation from the default combination state and to any other state. So you can see this section views one shows a top measurement, and then we add it from the general combination state, as you see, and will be visible on the section view. The 156 value will appear now as I'm going to turn. You can see there. We can create this combination stage either for the view manager or from the graphic toolbar, or from new annotate new from the ribbon. Yeah. So again, create a combination state. It's to organize display views of the model. Can be a saved orientation or cross section. It can be even an exploding view or assembly view. Also, we can use combination state to organize the 3D annotation, as I showed you, in groups or name them. Yeah. Let's go to the next slide. So these slides give you a brief overview of the product development process from design stage, and also reflect on manufacturing and machining part of the production through an example. The first few image on these slides shows a CAD model creation of a single box. You can see a sketch, a feature model, and a technical drawing. The common practice is to create technical drawings for manufacturing instruction, and that process is about to change with MBD. by providing a more organized, visualized, annotated 3D model with intricate instruction and guidance. Then on the next pictures, you can see the CNC machine and how the sheet material cut to a 2D shape. Also, we'll make some scrolls for later bendings. The third, on the next pictures, you can see the heat bending process, manufacturing process, where the actual piece cut out is bended at the scroll lines and form into the final 3D product. This is a very really simple example where errors can happen, but imagine a more complex part and assembly with a defined PMI, or when we're working with expensive materials, errors in machining could cost a lot. So detailed instruction and well illustrated information is vital on this stage, even on the assembly stage. The more intricate guidance we have, the less mistakes will happen, with less time spent and less material wastage. And that's important in production. And that is what MBD helps with, really, with task-specific annotation, with more visual 3D representation, with a seamless transition of the CAD model transformed to computer in manufacture model. We give clarity with this annotation, notes, instruction we need, warnings if we need, and whatever we need to provide for a more successful production. Machining setups mistakes could be expensive and unnecessary cost. So that is why we're running a previous machining path and analyzing that machining path, and could save time and money. I want to mention this machining license for the NC assembly. We need that machining license, and I'm going to talk about that one in the later slide when we're talking about the tools, the Creo tools. Yeah, and I just mentioned here the CNC cutting manufacture process, but also we can mention here sheet metal for plasma cutter and laser cutter manufacture progress. We can use mold and cast cavity option. Yeah. So let's see the benefits. How would benefit MBD benefit us as a company? Improve communication and collaboration. PLM system incorporates email notification for request and document any changes made. Contribute to the concept of digital thread, the seamless information flow. Reduce error by using no noted annotation, 3D visuals, as I mentioned, the toolpath, run analysis and simulation is all reduce errors. Also streamline design process, reduce manufacturing times, as I mentioned, support recycling and eco-friendly solution. For example, using 3D modeling, MBD means no more paper drawing. So it's encouraging paperless design and reduce paper waste and reduce waste. So digital thread interacts with the digital content overlaid into a physical world. MBD is critical component for digital thread, and that's the source of the product information used during the product lifecycle. Here are 3 examples how modern age changes that we are able to change things, and we would like to bridge these problems with MBD, provided information and the digital thread. So quality assurance, visual inspection, inspection. So PTC has a new step check procedure, and is helping MBD and AI digital technology. So what is the step check does? Starts with the process of start to scanning a barcode of inspected product. Vuforia AR capabilities ensure quality control by recognizing faulty elements and give guidelines and instruction for the required tasks in the production line, so workers can easily identify and rectify these deviations. Second challenge is navigating the fast-moving job market. Employers are facing the challenge of job migration. People come and goes with their knowledge. New employee needs to be trained quickly, and AR technologies can simulate real-world scenarios, opening up new way of interactive learning and changing the old-fashioned classroom-based learning. So these reduce the training time and learning curves for employees. And enchanting service and maintenance sector is the next challenge. And for example, in manufacturing, the digital thread with AR could involve overlaying real-time production data, assembly instruction or maintenance information into physical machinery or equipment. This enables workers to have immediate access to relevant information and instruction, improve efficiency, accuracy, and safety. So I would like to put a bit of highlight on Creo tools. As I previously mentioned, PTC has a huge product range in Creo product. Technology has revolutionized our whole life. What used to be an hour of Photoshop to crop an image now is a simple click on an iPhone. And there are tools for every one of your production needs, some of which you may be not aware of. And we make changes continuously. And we have a different level of Creo CAD packages. The Design Essential, Design Advanced, and Advanced Pro, and even more better packages to extend your Creo capabilities. Let's mention some Creo tools. Some of them with a basic package, and some others needs to have the advanced package. During the webinar, I mentioned the CNC machining, which use the prismatic and multi-surface milling extension, which needs a machining license. That's to create the NC assembly. There is Creo View, the geometric and dimensioning and tolerancing, PTC MetCAD, advanced assembly instruction, mold design and mold analysis. So I mentioned a few. PTC offers you all, and we would like to encourage you to share your vision with PLM Central and ask our expert to explore customized solution that can simplify your workflow with these tools. Thank you for listening, and I would like to thank you for joining us today, and hope you learned something new today, or some question pop up in your mind. So hopefully see you on soon on our next webinar series, in webinar 2. Have a wonderful afternoon, and thank you again for joining us today. And thank you, Faber, as well, Stefan.